And we're back, and it's COMP3025, and it's week 5, lesson 5, part 4. And we're going to talk about view controller a little bit more. Again, here, view controller.swift, it contains this view controller that controls all the functions in your storyboard, right? Now, again, they want to use NS decimal number to control the currency, right? Because we're doing a tip calculator. Right? But for us, because you're going to be just making a regular calculator, my recommendation to you is that you don't need to do that, right? But if you notice, when we have our first view controller, you implement or you import the UI kit, which is part of every view controller framework that we kind of have, right? They talk about the class, how we inherit from UI view controller. We talked about that already, right? That's the first thing that they do. I'm not going to talk about this. These little prevention tips I'll let you kind of look at in terms of function body and everything else. We inherit, and we talk about, remember we talked about this kind of briefly, this life cycle that we kind of inherit. And if you notice, the class to the left of the colon, right, or to the right of the colon is what it is the class on the left, and to the right is the subclass. Oh, sorry, I'm wrong. The class to the left is the subclass, and the class to the right is the superclass of the colon. Right, which makes sense, the base class, right, just like we saw. So again, we did these IB outlets, we talked about this, and how we did declaration. And so when the scene loads, these UI components, they're created, and then they create this connection between the view controller and the storyboard. Okay, that's what they're for. I'm not going to talk about too much about automatic reference counting. It's all part of it. You can't turn it off and on in iOS 8. In iOS 7, you still had a choice of choosing auto reference counting on or off. And you always want to keep that thing on because it keeps track of your reference count, which is almost like a memory management system. Leave it alone for now. You should know ARC. You should know about ARC, but we're not going to really use ARC in this tip calculator, right? Okay, so again, we talked about the difference between weak references and strong references, and this is where they talk about ARC again, because strong reference counts increase your reference counts by 1 where weak does not, right? Weak does not affect the object's reference count, and that's why we use that, because it's less memory management. So think about allocating a temporary location with weak referencing, right? Strong, it's there, and we put it aside for good, yeah.
Is it more like a strong reference is kind of like a pointer to the memory location?
Correct, but it also puts aside some extra memory for us. So whenever we want to put a strong reference, it means we want to put aside this memory and we don't want to lose it, right? Weak is like a temporary location, almost like an anonymous class or anonymous function, right? It's there when we need it, and when it's gone, it disappears, right? So it doesn't increase the reference count, if you will, right? Whereas it's a weak connection. It's a reference. We create a reference to our objects on the storyboard, but we don't increase the reference count. Something new that Apple has imposed in iOS 8. We talked about.
Kick old references out.
No, it just means that it increases the amount of memory. It's just different memory usage, and sometimes it's better to use strong references because of performance. When you want, there's certain performance issues, there's reasons to why. Yes, to allocate. But for now, we leave it the way it is, as is. Don't worry about it for now. We just mention it, but that's all we're going to talk about. So I'm going to go and look at the code. So this is where, inside the calculator, it's going to start doing things like, we're going to use the let, so a constant. We're going to start inside the, and again, Apple calls, when we do classes for Apple, and this is where it's kind of funny, they call the constructors initializers. That's just what they're called, right? Let's go back. So when we hear the term initializers in Apple Swift terminology, it means it's the constructor, okay? So if I go to my view controller properties and I see a little bit of code, when I do this, let decimal 100, this is our new thing, is equal to NS decimal number, right? We're using the NS decimal that exists in the Objective-C world, right? And we're assigning it a string value of 100, right? We're converting it. We're saying NS decimal number. We're saying let this number, NS decimal, is equal to an NS decimal number of 100. Why? When we can just use float or double, right? For us, it's enough, right? It's not going to be as accurate a tip calculator, right? But it's only a goddamn tip, right? It's going 15% or 18%, right? It doesn't have to be like the financial calculations for us from an accuracy perspective. If you give the guy an extra penny, it's not going to matter, right? Right? So that's why I know why they're doing it, because they want to introduce, from a financial calculation perspective, they want to bring in NS decimal, but it's really not necessary. And you would put this let. The reason why we're creating them as constants is because you want the 100 decimal that's 100 to equal to 100. And you want this decimal 15% to equal 0.15. Well, the easier way for me to do it, and let's just do that, and we're going to do that here in this calculate tip. Now, where does it exist? They want to put it here, right, inside of our view controller class, right? If you notice, it says line 17, 18, 19, and 20, right? And this is, it's used, these constants that are going to be used in the calculate tip method, but they're constants as part of the entire class. They're constants that are instance constants, if you will. Like instance variables, they are available to the entire class. If I don't declare them as private or whatever, then they're there. So I say let, and this is where I start programming, and I'm going to say decimal. Instead of decimal, I'm going to call it float, because or double, right? Let double 100 is equal to 100.00 or 100.0. If I do this and go next, right? The type this does type inference. If I want to specify what kind of value this is, I could simply use, double as an example. So here's my double type, right? And I can be explicit, right? This is a double, right? Let double 100 is equal to 100. Again, if you really want to follow the book, you can say NS decimal. But this is what we're really doing. We're saying it, let's equal it to 100, right? And then let's do the next piece. Let's go let decimal 15, which we wouldn't say decimal, but let double 15, and we're gonna explicitly declare it as a double. We don't have to, by the way. Equal to 0.15. So 15% basically is what we're going to be using here. Okay. Again, we want to, it says initializer parameter names are required, right? So when I create constructor parameter names, I have to put them in. I can't just, pass in values without the parameter name, right? So let's take a look at what these look like. Type inference example, if I go back to my code and I don't put this double value in here, because these are double values, we know that this is a double. So if I go like this, and take these out, Swift will also accept these because we know these are doubles, and it'll kind of roll to the nearest type that makes sense for us, right? That's all this thing does. Okay, let's continue on. So here's my view did load, and this is where we first start off. We say, hey, let's use my input text field and let's activate it. Let's say become first responder. When I use become first responder, as soon as I launch my view did load, it activates my text field, which brings up the keyboard. That's what it does. That's what this element does. So again, we're going to activate the text field. So text field, what did I call it?
Input.
Thank you. Input text field. Okay, and then if I start typing first responder, right, it won't do it. If I say become first responder, that'll work, right? And I can put, if I want to, I can put a semicolon here, and it's not going to complain because, again, just to remind you guys, Swift knows that we come from other languages, right? Now if I run it just like this, I haven't made a couple changes, just a couple of these variables plus becomes first responder. When I run this thing, automatically, right, it brings up the keyboard, right? So as this thing launches, my keyboard comes up. Now it goes down here into my text field, right? This is a trick. Like I said, same thing with this. If I do this, hey, look at my custom tip percentage. I got an issue here, right? With my my layout. Should I correct it now? Apple says no. Don't bother. Leave it alone for now, and keep working. Let's keep doing this thing for another 5 minutes, and we'll stop. And then I let you guys do the rest on your own. Okay, method definitions. Again, we use the function keyword or func keyword. We use override to override the base definition, right, for the function or the method. It reminds me a lot of the old way we used to do things with JavaScript, actually. But now we're using func instead of function. It's very JavaScript-like, actually. When I use this thing, it reminds me a lot of JavaScript. So again, the calculate tip is the action, right, as specified by IB action, and in response to the text field's editing changed event and the slider's value changed events. Remember, because it's a shared event handler, if you will, right? And we're going to add in the regular code, this code in lines 32 to 81, this piece here. Look at all the stuff it's adding in here into the text field. So it says, let the input string, this is a new variable, equal to my input string that I'm getting from my text field. So this is where I'm going to get my 1, my 2, my 3, my 5, whatever it's going to be. It's an input string, right? So let's do that. So if I was to, sorry. Now, what if I use var? Would that be okay? And the answer is yes. Why would I use let over var? Let means that it's a constant. As soon as I put stuff in there, it's done. It's changed forever, right? So to me, it makes more sense, makes more logical sense to make it a variable. Input string, right, is not a constant, and it's equal to my, what is it called again? Input text field? Input text field dot text. So now I'm using it as a getter, right? Now look, does it complain? It doesn't. And if I take this input string just to test it out, so I'm going to use a print line, and I'm going to take my input string and put it in there, right? Just from an understanding perspective, I'm going to kick this out back out to the console, if you will. I'll save it and I'll run it. It looks largely like this. So here I've got this running, and here I'm in the console. And if I click 1, 2, 3, look what's happening. 4, 5, 6. It doesn't clear. It keeps adding, concatenating to my input string, right? This is why, because I'm using var. Let's try it again, and let's see if it does something different with let. So here's var, and here's let. Let means it's a constant, right? Let's try this again, and tell me the difference. So var, let. 1, 2, 3, 4, 5. Any difference? Does it make sense? Here's a question for you. Does it make sense that I'm using let? Why am I using let? It's saying this. It's saying don't let my input string change after I've declared it. And that is declared every single time I click on that button. As soon as I click on my keyboard, it's listening for a keyboard click, and it's recreating that input string again and again. It's not once and for all. It's every single time I create it, and once it's done doing its action, it erases it. It's gone. Doesn't care about it anymore. So if I have nothing left inside that calculate tip method, right, it's gone. So I can do a let every single time because I am making it a constant. I'm creating it when I click on the button, and then it's gone. But somehow, if you think about it, it's carrying on. I'm getting, instead of getting the 1, 2, 3, 4, 5, it maintains what I put in there. It remembers, right? Why? It doesn't remember because of this, guys. It remembers because as I'm clicking into the text field, the button, it's adding my numbers into the text field. That's what it's doing. An example of that would be this, right? So I run my function, which makes sense actually, right? Normally for a calculator, I'm going to go 1, 2, 3, right? And I'm going to click the plus button, 4, 5, 6. I'm going to click the equals button, and then it's going to take 1, 2, 3 plus 4, 5, 6, right? And it's going to do something. When I click the plus button, if you're going to make a calculator of your own, it's going to delete the input string. It's going to wipe out the value of input text string, input text field. It's going to wipe it out temporarily. When you press the plus, it's going to carry that value, whatever's inside that input string, into something else, and we're going to have the first operand, the left side of the equation, right? Then you're going to click, once you click the plus button. When you click the other numbers, it's going to put the other numbers in the other operand, and it's going to wait for you to click the equals button, which we don't have yet, for it to do the calculation, right? And then obviously you need some kind of clear, right? Because we don't have a clear button, right? So otherwise you can't calculate again. It won't know what to do, right? Start over. If you click the button again, what is it going to do? It's going to overwrite the first operand. You can make something like that happen, right? So think about what's going to happen, because right now in our design pattern, right? Here's our design pattern. And again, the guys at home, I'm sorry you can't see it. I'm not quick at drawing it as much as I'm doing it here for whatever reason, right? But I have my keyboard that comes up halfway. Here's my keyboard, right? And what's happening is if I press these buttons, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then, sorry, my other part of my keyboard is here with 0, right? I think it's 0 down here. You have this button here that deletes, this X button here that kind of deletes, and you have nothing in this place here, right? So you're probably going to make, for your calculator app, you need a plus button that you're going to, a custom plus button that you're going to create, and a custom minus button, plus, minus, division, whatever, and some kind of equal sign, right? I would start with this for you guys. Can you do this first? Use the plus operator. Use the buttons. Make it equal something. Display it out here in some kind of text field. Do that first, right? Then work with the minus. Once you get the plus, the minus is easy. Same thing with the times and the division, right? So that's how I would do it. And then use this keyboard. Why would you reinvent the wheel and make your own keys? You could, like Kevin did, right? But, and that's fine because it gives you more control, right? But if you want it to look like Apple-style keyboard, use what's there, right? And that's it for me. I'm going to leave you guys to do the rest.
Why the constant though? We never.
Oh, because what they do is they want to protect it with inside that calculate tip function, right? So inside
It's
that,
never gonna change.
correct. So I can't change it physically inside there. From a code hinting perspective, it's going to kick up an error.
Just a same name.
That's right. And Apple's all about safety.